A mixture of ethanoic acid, ethene, and oxygen is passed over a catalyst at 200 degrees Celsius to manufacture ethyl ethanoate. Ethyl ethanoate is an ester. Ethanyl ethanoate, sorry. Ethanoic acid, ethene, oxygen, ethynyl ethanoate plus water. The reaction is exothermic. Draw a reaction pathway diagram for this reaction. So the axis has to be labeled first. So here I will write progress of reaction, and on the y-axis I will write energy. The reactants should be on a higher level, so reactants are CH3COOH. The other reactant is ethene, so CH2 double bond CH2 plus half oxygen. These are my reactants. From the reactant level I start, I reach a peak, and then I drop, and then I make the product. The product is basically CH3COO CHCH2. CH3COO CH double bond CH2, and the other product is water. I will have to label my enthalpy change. So let me pick a better color arrow. This is the activation energy, by the way. So this is my activation energy, and my enthalpy change is going to be downwards. So enthalpy change is going to be like this, and I will label it delta H. Use ideas about bond breaking and bond making. Why this reaction is exothermic. So we will have to mention that few universal statements, which is bond breaking step is endothermic. This is always true. Bond breaking step is always endothermic, and bond making step is always exothermic. Why is a certain reaction exothermic? Because during the bond making step, it releases more energy. So more energy was released than absorbed. So more energy is released in bond making. More energy was given out during bond making than absorbed during bond breaking. So you absorbed less, but you released more. Peroxo disulfate reacts with iodide ions in aqueous solution. Iodide ions are oxidized in this reaction. State how the equation shows this. So we'll have to mention that iodide ions are losing electrons because there was a negative charge on them. The oxidation state, the oxidation number was -1, but the oxidation number for iodine is equals to 0. So we can say that the oxidation number is increasing, or you can say iodide ions, I minus iodide ions, are losing electrons. And we can elaborate this statement by saying that iodide minus ions oxidation number changes from -1 to 0. Their oxidation number was -1 when they were iodide ions. Now it's 0. Table 7.1 shows the relative rate of this reaction changes when different concentrations of peroxodisulfate ions and iodide ions are used. Using the information in table 7.1, describe how increasing the concentration of each ions affects their relative rate of reaction. So I can see comparing reaction 1 and 2, the concentration of I minus is same, and the concentration of peroxodisulfate ions is doubled. So the rate also doubles. So we can say that as concentration of peroxodisulfate ions increases, the rate doubles. So you can say as concentration increases, or you can say doubles, rate also increases / almost doubles. Almost, because it's not actually doubled. Moving on, when we talk about iodide ions, we'll have to pick a reaction where the concentration of peroxide disulfate remains same, but iodide ions changes. So you comparing reaction 4 and 5, peroxide disulfate remains same, but iodide ion concentration doubles, and you can look at the rate of reaction. Rate of reaction also almost doubles from 34 to almost 69. So you will say that concentration increases, doubles, almost doubles, reaction doubles. So as concentration increases or doubles, rate also almost doubles. Fe3 ions catalyze this reaction. Explain how catalysts increase the rate of reaction. So basically they provide alternate pathway with decreased activation energy. They provide alternate pathway with decreased activation energy. And since the activation energy is lower now, so now more particles qualify for this reaction, which means more particles have energy which is equal to or more than activation energy requirement, equal to or more than activation energy value. Copper reacts with concentrated nitric acid to form copper to nitrate. State the meaning of AQ. It means that it's dissolved in water basically. So it's a solution in water. An excess of copper is added to 25 centimeter cube of 16 mole per dm cube nitric acid. Use this information together with the equation to calculate the volume of NO2 formed. The gas release is measured at room temperature and pressure. So let's see. How many moles of nitric acid do we have? So we have 25.0 over 1000 times 16.0. The moles of nitric acid is going to be 0.400 mole. Now we can see that 4 mole of nitric acid give me 2 mole of nitrogen dioxide gas. So how much moles of, let me reset it. Yeah. How many moles of nitrogen dioxide gas do I get? So ratio was 4:2, right? Using this, the answer is going to be 0.400 divided by 2 is equals to 0.200 mole. Using the ratio, I get 0.200 mole nitrogen dioxide gas. Volume of nitrogen dioxide gas is going to be the moles times 24 decimeter cube. So using this equation, we get 4.80 decimeter cube, or if you're doing in centimeter cube, then don't forget to write 4800 centimeter cube. When heated, copper nitrate decomposes to form copper oxide, nitrogen dioxide, and oxygen gas. So copper nitrate decomposes to give me copper oxide, nitrogen dioxide, and oxygen gas. Left side has 1 copper, right side has 1 copper. Left side has 2 nitrogens. I will add a 2 before NO2, so right side also has 2 nitrogens. Left side has 6 oxygens. Right side has 2 2s are 4. 2 over here, 1 over here. So right side has perhaps 7 oxygens, which is not cool. We can decrease the oxygens by adding half before O2, so that is also okay for us. To a small sample of copper nitrate, a student adds aqueous ammonia drop by drop until it is in excess. If you have watched my recent video about salt analysis, you would know that you will see pale blue precipitates which are going to give you a dark blue solution. So pale blue precipitates, and excess it gives you dark blue solution. Pale blue precipitates dissolve in excess aqueous ammonia to give dark blue solution, right? The student repeats the experiment but adds aqueous sodium hydroxide instead of aqueous ammonia. What's observed? So this time you see pale blue precipitates which do not dissolve. So pale blue precipitates, or you can see blue precipitates insoluble in excess. They do not dissolve. They would dissolve in aqueous ammonia. Iodine reacts with chlorine to form iodine 1 chloride. Iodine 1 chloride reacts in a similar way to bromine. Iodine 1 chloride reacts with ethene in an addition reaction. Draw the displayed formula of the product of this reaction. So let me recall the reaction with bromine. If you take ethene and you react it with bromine, which is Br2 by the way, the two carbons would stay in the same place, the hydrogens would stay in the same place, the double bond would be gone because it's an addition reaction. Both carbons would receive one bromine atom each. So similarly, the double bond would be gone, hydrogens would be in the same position, one carbon would get iodine, the other would get chlorine. Iodine 1 chloride reacts in a similar way to chlorine. Iodine 1 chloride reacts with ethane in photochemical reaction in the presence of ultraviolet light. If it's UV light, you know the name of reaction. The reaction is none other than the substitution reaction. Suggest a simple equation for the reaction between iodine 1 chloride and ethane. Ethane is C2H6 based on the general formula. Iodine 1 chloride is ICl. You know what happens in substitution? You remove one hydrogen, you add one chlorine. ठीक है जी? So what you do is, you remove one hydrogen, C2H5, and you get like iodine replaces the hydrogen and the other hydrogen goes away with chlorine, HCl hydrogen chloride. If you want to change it, you can also write it like this. You can replace the hydrogen by a chlorine or make HI. Both is okay, both should be acceptable. The point is, one hydrogen is substituted. Draw the dot and cross diagram for a molecule of iodine chloride. Iodine is group 7, chlorine is also group 7. So I will draw two circles, circle 1, circle 2, iodine, chlorine. They both make single covalent bond because they want to make one bond each. Iodine has 6 unbonded electrons in the valence shell. Chlorine also has 6 unbonded electrons in the valence shell. That's it. By the way, these electrons are known as lone pairs, and this electron pair is known as the bond pair. If someone from AS watches this video, they would know that. Iodine 1 chloride reacts with chlorine to form iodine 3 chloride. The reaction is investigated at 200 degrees Celsius in a closed system. The reversible reaction reaches an equilibrium. Describe two features of a reversible reaction at equilibrium in a closed system. So the first thing should be referring to the rate of reaction. So rate of forward reaction is equal to rate of reverse reaction. Rate of forward reaction is equal to the rate of reverse reaction. Another thing is concentration. So you would say concentration of reactants and products stay constant. The concentration reach an equilibrium, they do not change no more. They're going to stay constant. Moving on. The pressure of the equilibrium mixture is increased, the temperature is kept at 200. ICl is dark brown, ICl3 is yellow gas. So ICl is dark brown, ICl3 is yellow gas. Prediction. So what's my prediction about the color of the equilibrium? If pressure is increased, it will favor the side with less gaseous moles. If I go back and if I see there are 2 gas mole on the left hand side and 1 gas mole on the right hand side. So the color should become more yellow, and the reason is that there are less gaseous moles on the right hand side, so high pressure will favor the right hand side. So it becomes yellow, yellow, intensity increases or the coloration becomes more yellow, and we would say there are less gaseous moles on the right hand side. As there are less gaseous moles on the right hand side, so increased pressure favors this. Air contains a mixture of gases including noble gases, neon, argon, krypton, and xenon. These noble gases are monoatomic elements. So what do we mean by monoatomic? They exist as atoms. Atoms are unbonded. They exist as single atoms and are unbonded with other atoms and are unbonded with other atoms. State why noble gases are unreactive. So we know this, right? They do not need to gain, lose, share electrons because they have a stable electronic configuration. They have a complete valence shell. So they have a complete valence shell. They do not gain / lose / share electrons. They don't need that, right? State why fractional distillation can be used to separate a liquid mixture of neon, argon, krypton, and xenon. The reason is because they all have different boiling points. They have different boiling point values. So if you somehow cool and convert the air into liquid and then you heat it again, they would boil at different temperatures and each gas would be boiled at a different temperature. State which noble gas, neon, argon, krypton, and xenon, has the fastest rate of diffusion at 20 degrees Celsius. So here you should understand that temperature is same for all. Temperature is same. What is the other factor that changes the rate of diffusion? So it is the one with smallest molecular mass, atomic mass, neon in this case, as it has smallest relative atomic mass. Simple as that. Air also contains oxides of nitrogen that are pollutants. State 1, adverse effect of oxides of nitrogen. So when we talk about oxides of nitrogen like NO2, those are acidic oxides, right? So they can cause acid rain. Another thing that you would know is that they cause photochemical smoke, but acid rain should come first to your head. With the aid of a simple or word equation, explain how oxides of nitrogen such as NO are formed within a car engine. So what actually happens is that there is nitrogen in the air which is going into your engine. There is oxygen overall there also. They form 2 moles of nitrogen oxide gas. Let's move on. Explain how. So I would say nitrogen is present in air and very high temperature causes the reaction to initiate. Now let's go for part 11. Table 11.1 shows some information about the homologous series of unbranched carboxylic acids. State one of the characteristics of a homologous series, one of the characteristics of a homologous series that it has a general formula. Deduce the general formula of the homologous series of unbranched carboxylic acids. So if you remember this from the syllabus, they have a very similar formula to alkenes, but there is always double oxygens. You can see that in the first compound, the formula is CH2O2. In the second one, it is 2 carbons, it is 4 hydrogens and oxygens. So you can see as the carbon increases by 1, the hydrogen increases by 2, and O2s are always constant. So CH2O2. Describe 2 other characteristics of homologous series. So you can say that they have similar kind of chemical properties. Number 1, they have similar chemical properties as they have same functional group. All of them have same functional group within the series. So this is the first property we can mention. Another property can be that they have a gradation in their physical properties. So they have gradually changing physical properties. They have gradually changing physical properties. An aqueous solution of propanoic acid is a weak acid. Define the term acid. We have already defined it, right? They release H plus ions. Butanoic acid reacts with ethanol to make an ester. State the name of the ester made and draw the displayed formula. Displayed formula means all bonds showed. So if butanoic acid is the acid and ethanol is the alcohol, the name is going to be ethyl, because alcoholic part names come first, ethyl, and then you will say butanoate. I would suggest, in order to draw the ester, first draw this thing. This should be your ester linkage. This is your ester linkage. And then with an ester linkage, the left hand side is your carboxylic acid side and your right hand side is the alcoholic side. So within left side, draw 3 more carbon atoms because one is already drawn. So left side has 4 carbons in total and the right side should have 2 more carbon atoms because of the ethanol. Draw the hydrogen atoms like this. Draw the hydrogen atoms like this. And now your ethyl butanoate ester is complete. Ethanoic acid is a liquid at room temperature. Describe the changes in the arrangement and movement of the molecules of ethanoic acid when it's heated from room temperature to 120 degrees Celsius. So if I go back and if I notice, ethanoic acid has a boiling point of 118 degree, which means that it will also boil during this change. So we'll have to mention that it is changing from basically liquid to gas, right? So molecules will gain kinetic energy, they will gain the heat energy as the temperature increases, and they begin to move faster. So their motion increases as they gain kinetic energy, and since they are becoming gas molecules move faster. So they move faster, and since they were liquid, so few molecules were touching each other, but now they are not touching at all. So molecules move away and are becoming further apart from each other. They are becoming further apart from each other. This is how their spacing is changed. And now they were liquid, so they were arranged randomly, but now they were arranged even more randomly. So arrangement changes to even more irregular arrangement. This is how you would explain their arrangement and their motion. I hope it's clear to you guys. Stay tuned.